Hi, it's time for another math easy solution. Turn to discuss further into the substitution rule for integrals and look at part 3 of the example series. I'm going to go over just one example today. It's a pretty useful one. Before I get to it, I want to recap on the substitution rule, which you could learn more about this in the proof of it in the video links below in the description. Basically, if u equals g of x is a differentiable function whose range is an interval I, and f is continuous on I, basically we're going to plug this inside this function here. If you have f of g of x, this just means if the range of this is basically has a range I, inside this, when you throw it inside, it will be the new domain of f, and f has to be continuous on here, and this differentiable just means you could take the derivative of u. So basically, if you have a function, let's say like this, f of g of x times g prime of x dx, you can basically substitute u equals g of x inside here. And then also the differential du, find that over here is going to be g prime of x times dx, or over here, and replace that with du. So learn more about that and differentials in the video links below. Basically, the example I'm going to go over is this one right here, which says find the integral of basically square root 1 plus x squared times x to the power of 5, and then dx right here. So as you can see, the idea of substitution is to simplify this. And it's pretty obvious from this case that the best way to simplify this is by replacing 1 plus x squared with u. So we basically let u equals to 1 plus x squared right here. And now when we take the derivative, we get du equals to, or get the differential. Du is going to be now 2x, and then dx here. Always remember the dx. So when we have this, but then when we look over on this side, there's an x to the power of 5 dx. So we have to make the x to the power of 5 basically replace this little thing with du or u. So the idea of doing that, if we basically equate it here, we'll get basically x to the power of 5 dx right here equals to, well, if we write this one in here first, an idea is to do basically, if we write 2x dx right here, just so this is du, then divided by 2, and now we put an x to the 4. So basically I'm just writing x5 dx, but including this in there just because we're gonna have to replace it. So you can see over here we have this part like this, and this is basically our du. So x to the power of 5 equals to basically du divided by 2 times x to the 4. So now we just got to replace this x to the 4 in terms of u or du, and we could do that by basically recognizing this part. If we rearrange this, we're going to get x squared equal to u minus 1. Now if we square both sides, we'll get x to the 4 equals to u minus 1 squared. So we have this one, now we have this x to the 4 unit. But now we could even simplify this further or expand it out. This will be equals to, well, u squared, and then this is going to be this times this, and then minus, and then plus this times this. Just simple expansion. You're going to get this is going to be 2u, and this is going to be plus 1, negative 1 times 1. Learn more about expanding in my video links below. Yeah, so now we're ready to basically plug everything back into this original integral. So we're going to get now, this will equal to, well, this is square root of u. And now the x4 has become this part here, so which is u squared minus 2u plus 1. And now the dx, the x dx, that's going to be, well, du over 2. So we have this part right here. So du over 2 right here. Now we could even simplify this by expanding this all out. This will equal to, well, 1 over 2, just put this out of there. And square root, integral of, now we can times this inside, we're going to get basically u of, this is 2, and we have to add up the power. We can add up powers. The square root is 1 over 2, so we add 2 plus 1 over 2, minus 2 to the u, which is 1 plus 1 over 2. And then the last one, this 1, is going to be, well, u to the power of 1 over 2, or square root of u. And again, we put a du at the end of this one. So now we add these up, simplify it further. We're going to get integral here. 2 plus 1/2. We could use common denominator of 2, so multiply this by 2, that's 4. So 4 plus 1 is 5 over 2. And then minus, this is going to be 2u. This is a 1 plus 1/2, that's just going to be 3 over 2. And this is just going to be just u 1 over 2. And again, put a du here. And now we could basically take the integral of this. So we're going to get a 1 over 2. And then in bracket here, the integral or the antiderivative of this is just going to be u to the 7 over 2. And then we also put a 2 over 7. So when we take derivative, this multiplies here and it cancels, and then subtract by power of 1, and that becomes 5 over 2. So we get that. Now this part right here, this will just become now u, put 5 over 2, and now it's going to be, then multiply here 2 divided by 5, but there's already a 2 here, so we'll just put a 4 over 5 here. And now plus this part right here, that's going to be u 3 over 2, and then put 2 over 3, just flip that there. So we have this one now. Now we also have to add a constant. So plus constant. Now we can divide it out by 2. So we'll get basically u7 over 2 divided by 7 minus divide 4 by 2. That's just 2. u5 over 2 all divided by 5, and then plus right here just going to be 1 over 3 times by u 3 over 2, then plus c. That's 3 right there. So now we could basically plug back our 1 plus x squared inside u, and we'll get our final answer. That's just going to be now 1 plus x squared, 7 over 2, divided by 7, and then minus 2. 2 divided by 5, this is 1 plus x squared, and then 5 over 2, and then plus 1 over 3, 1 plus x squared, 3 over 2, and then the last one just plus c, which is any random constant number. And there is our derivative, our integral right here. And we could always double check by taking the derivative, and that's a good way to check it. And if I'm not going to do it right here, it's just a bit more tedious, but you could check it for yourself, and you should get back to this one here, which is square root 1 plus x squared times by x to the power 5. Anyways, that's all for today. If you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.